Hello everyone, today we are going to start lecture 05 of class 8 mathematics chapter number 1, which is rational numbers. In this lecture we are going to learn about division of rational numbers and properties of division of rational numbers along with some questions. So let us start by defining what is division of rational numbers. Let x and y be two rational numbers. Let x and y be two rational numbers. Then x divided by y, that is division of x and y, is defined as multiplication of x by the reciprocal of y, that is multiplication of x by multiplicative inverse of y. As we have seen in the subtraction of rational numbers, that subtraction of two rational numbers is nothing but the addition of negative inverse of other number with the first number. Similarly, division of x and y is nothing but the multiplication of x with the multiplicative inverse of the number on the right hand side of this symbol. Okay. Obviously here y should not be equals to 0, as I have already explained in the definition of rational numbers that we cannot have anything in the denominator which can be 0 because it is not defined. Similarly, we can also define division of rational numbers, right, in the fractional form. That is, if a upon b and c upon d are two rational numbers, then a upon b divided by c upon d is equals to, now what it is according to the definition, now a upon b should be multiplied by the reciprocal of c upon d, and we all know reciprocal of c upon d is called multiplicative inverse, that is inverse of c upon d, which is nothing but interchanging of numerator and denominator, that is d by c. So this is how we define division of two rational numbers. Now let me take this opportunity to tell you that sometimes you get expressions like a upon b whole upon c upon d, right? How can you solve them? Now if you see, it is nothing but whole a upon b can be treated as a numerator, so a upon b is getting divided by c upon d, so you can treat it like it and then you can apply the principle, that is d upon c. Example, suppose you have 3 upon 2 whole upon 5 upon let's say there is nothing, 5 upon 1, so it will be 3 upon 2 into, now this 5 upon 1 will get reciprocal, so it is like this, so you will get 3 upon 10. So this is how you solve expressions like this. I hope it is pretty clear. Now let us move on to the definition of dividend, divisor and quotient. You must have heard these terms. Now let me define formally what is known to be dividend. Okay. So let us first define dividend. So what is dividend? It is the number to be divided. The number to be divided is called the dividend, right? That is something you write in this column. I'll show you it with the help of a diagram, but for now let us define them formally. What do we mean by divisor? Now if something is getting divided, there must be someone who must be dividing it. So this is the number which divides the dividend. Okay, let me write it a bit correctly. The number which divides the dividend is called the divisor. And what do we mean by the word quotient? How many times the divisor divides the dividend? So that is called quotient. Okay, the result of division is called the quotient. Okay, now let us see by diagram what do we mean by dividend, divisor and quotient. Suppose you have to write 10 upon 2 is equals to 5. Okay, so in this case you will write it like this: 10 divided by 2 will give us 5. Now this 2 is called divisor because it is dividing, and what is getting divided? 10. So this is something called dividend. And what is the result of this division? What are you getting? We are getting 5. So this is quotient. There is one more thing called remainder. In this case the remainder is 0 because when you divide 2 by 10 you will get exactly 10 and you will get the remainder as 0, right? Suppose if there was 11, then there would be no quotient, or you can say in that case quotient was again 5 but remainder was 1. Okay, in that case we could say that the number 11 is not divisible by 2. Okay, because here the number 10 is divisible, so the remainder is 0. One more thing to be noted is again division by 0 is not defined. That is, divisor can never be 0, or you can say denominator of a fraction can never be 0. That is, I have already explained. Okay, so this was all about dividend, divisor and quotient. So with the help of an example, let me explain it a bit further. Suppose you divide a upon b is getting divided by some c upon d, and you are getting a result a upon f. Okay, then what is this which is getting divided? That is dividend. What is it which is dividing it? That is called divisor. And what is this fraction a upon f which we are getting? That is the quotient. Okay, and what will be the quotient here? Obviously it will get reciprocal. A by b cross d by c will be the quotient. So this was all about dividend, divisor and quotient. Now let us do some questions on them and clarify the concept further. Okay, so let the question be: divide 3 by 5 by 4 by 25, right? It is very easy. So we will start by writing formally. We have to divide 3 by 5. So 3 by 5 is getting divided. And who is the divisor? It is a dividend. The divisor in this case is 4 upon 25. So following the definition of division, actually 3 by 5 should be multiplied by reciprocal of 4 by 5, 4 upon 25. So we have like this. So again, further solving it, we will get 25 upon 4. Now clearly we know the multiplication of rational numbers. Okay, in this case numerator would be multiplied together and denominator would be multiplied together. Since in the cross multiplication you can cancel out the common factor because now they are in the form of fraction, you can divide both of them by 5 and you will get 3 into 5 whole upon 4 into 1, right? 4 into 1, which would be 15 upon 4, which is the final answer. So it was a very easy question. This is how you can carry out division of two rational numbers. Now let us take another question which involves a statement. In the statement, question simply speaks that the product of two rational numbers is minus 28 upon 81. If one of the number is 14, find the other number. Okay, let the other number be x. There must be some other number. Let the other number be x. Okay, So if you take the other number x, then arranging the question or arranging the equation according to question, we will get, then according to the question, comma, it says product of two numbers is minus 28 upon 81. So minus 28 upon must be product of something. So let's say product of these two numbers x and the another number is given to be 14 upon 27. This product comes out to be minus 28 upon 81. Right. Now how do we solve it? We all know that if, okay, I can write it here. We all know that if AB equals to C, then B is equals to C upon A, or A is equals to C by B. So we can again use the same principle here. So what is x? X should be minus 28 upon 81 whole upon 14 upon 27. And I already told you how to solve it. This is nothing but minus 28 upon 81 divided by 14 upon 27. See here we can see, what is it? It is C divided by A. Okay, so now minus 28 by 81 divided by 14 by 27. So again, if you do the reciprocal of the right hand side, you will get 27 upon 14. Now again, cancelling out the common factors, 14 will be divided by 14 by 1 and 28 would be divided by minus 2. Now you can divide 81 by 27. So 27 divided by 27 equals to 1. 81 divided by 27 is equals to 3. So you will get x equals to minus 2 into 1 whole upon 3 into 1, which is equals to minus 2 upon 3. You should always write the number in words because you took it as x. So you should not leave the answer here and you must write so, comma. This line should come here. So the other number or the other required number. So the other number is minus 2 upon 3. Let us verify it. Multiply minus 2 by 3 with 14 into 7. Now minus 2 into 14 would be minus 28 and 3 into 27 would be 81. So yes, our answer is correct. So you can verify your answer. Okay. So, to confirm that it is the correct answer or you have not committed any calculation mistake. Right. Let us take another example on the similar pattern. Now this time the question says, by what number should we multiply? Now by what number should we multiply this? So the product may be this. Again, it is the same question but the language is a bit different. So you can again take by what number? Let the number be x. Let the number be x. Let the other number be x. So we have to multiply x with 3 upon minus 14 to get 5 upon 12. Simple. Then according to the question, x into 3 upon minus 14 is equals to 5 upon 12. Okay, again the same question. 5 upon 12 whole upon 3 upon minus 14, which again implies that x equals to 5 upon 12 divided by 3 upon minus 14. We are treating 5 by 12 as a numerator and 3 by minus 14 as a denominator. Again, here x would be 5 upon 12. When the division sign changes into multiplication, right hand side of the division sign gets reciprocal. Okay. So again, you can cancel out the common factors. Dividing them by 2, we will get 6 and dividing it by 2, we will get minus 7. Right. So the final answer would be 5 into minus 7 whole upon 6 into 3, which simply implies that x is equals to minus 35 upon 18. So you can write in words. So the required number which should be multiplied by 3 by minus 14 is minus 35 upon 18. So this was all about division of two rational numbers. We have seen the division of rational numbers in the form of fractions. We have done some questions in order to how to use the method. Now let us move on to an important topic, which is properties of division of rational number. We have studied properties of addition, subtraction, multiplication. Now we should also study properties of rational numbers, similar kind of properties. So let us move on to the properties. Now, what is property number 1? There are some properties of division, right? Property number 1 states that if A upon B and C upon D are two rational numbers such that C upon D is not equals to 0. Why do we have to see that? Because if you are going to divide A upon B by C upon D, then C upon D will act as a denominator, and denominator should not be equals to 0 because division by 0 is not defined, right? If A upon B and C upon D are two rational numbers such that C upon D is not equals to 0, that is, we have ensured that denominator will not be equals to 0, then only then A upon B divided by C upon D is always a rational number. So what is the name of this property? Can you guess it? This property is called closure property, right? So this simply states that the set of all non-zero rational numbers, the set of all non-zero rational numbers is closed under division. That is, if you divide a rational number by a non-zero rational number, then you'll always get a rational number. If you want, you can verify it with the help of an example. You can take as many examples as you can, but for the sake of explaining this property, let me take an easy example. Let us divide 1 by 2 by 2 by 3. Again, 1 by 2 and 2 by 3 both are rational numbers, and 2 by 3 is not equals to 0. So clearly, when we change divide into multiply, we get 3 by 2, and the final answer comes out to be 3 upon 4, which is again a rational number, comma, which is a rational number, right? So this was the first property, which was nothing but the closure property. Now let us come towards the second property. Now what does the second property states? Second property simply states that for any rational number A upon B, comma, we have A upon B divided by 1 is equals to A upon B, and A upon B divided by minus 1 equals to minus A upon B. It is pretty clear that if you divide any number by 1, you will get the number itself. We have already seen we can write 5 equals to 5 upon 1. Similarly, you can write 2 upon 3 divided by 1 equals to 2 upon 3. And if you divide any number by negative of 1, that is minus 1, then also you will get only the negative of the number. Okay, so you can verify them as, you can easily verify them like A upon B. I am just verifying. Okay, divided 1 by 1 is nothing but A upon B, multiply 1 upon 1. You have done the reciprocal. So again, anything multiplied by 1 is 1. That is the multiplicative identity of rational numbers. Similarly, if you divide A upon B by minus 1, you will get A upon B into 1 upon minus 1, which is again nothing but minus A upon B. Because minus on a fraction can be put anywhere, either on numerator, either on denominator, or on the complete fraction. So this was property number 2, right? So multiplying by 1 or dividing by 1 do not change the question, but again you will divide by -1, then the number will become negative of itself. Clear? Let us come to the third property, which says that for any rational number, or you can say for any non-zero rational number. Let me write non-zero specifically so that there is no confusion. For any non-zero rational number, a upon b, comma, first a upon b divided by a upon b is equals to 1. Right? How? I'll verify it. Second property. Now first property simply states that if you divide a number by itself, you will get 1, which is obviously true. If you divide a number by negative of itself, that is minus a upon b, then you will get -1, then you will get -1, and third, if you divide a number again by negative of itself, again a by b is what? Negative of minus a by b, then also you will get -1. If you want to verify, you can verify them as follows. Let me verify this. A upon b divided by a upon b would become a upon b multiplied by b upon a. You will cancel them out with 1. So you will get 1 into 1 whole upon 1 into 1, which is equals to 1. Right? This was like this. If you want to verify this, you can take as a upon b. When you change the symbol into multiplication, it will get b upon minus a. So again, it will cancel one time. It will cancel -1 times. So the answer would be -1. Similarly, here you can do like this. Okay, so this was common, but you can again here verify that if you change the division sign into multiplication, you will get b upon a, and again cancelling them out, you will get -1. So this was all about properties of division of rational numbers. Also, you can clearly see that division of rational numbers is not associative, neither commutative, because a upon b divided by c upon d would not be equals to c upon d divided by a upon b. Okay, so we can write the division of rational numbers is neither commutative nor associative. So this was all about properties of division of rational numbers. Right? Now let us solve a question so that we can conclude what we have studied. Right? So the question simply says, divide the sum of 65 upon 12 and 12 by 7 by their difference. So let us first find out what is their sum and difference so that we can divide them by each other. Now 65 upon 12 plus 12 upon 7. Right? So again we will take the LCM of 7 and 12, which according to me should be 12 into 7, that is 84. Okay, so 84 is the LCM. Now 12 into 7 equals to 84, so we will have 65 into 7 plus 7 into 12 equals to 84, so we would have 12 into 12. Okay, now let us calculate what is 65 into 7, right? So it would be 455 and 12 square equals to 144 whole upon 84, right? So we should add the numerators now. So 144 plus 455 would be equals to 599 whole upon 84. So this was the sum, right? This was their sum. Now let us find out their difference, because the question says you have to divide the sum by the difference. So let us find out the difference. Again the LCM would be 84. Again the same figures would be there, so you will have 455 minus 144, which ideally should be equals to 311 whole upon 84. Now according to the question, you have to divide the sum, that is 65 by 12 plus 12 by 7. You have to divide this by the difference, that is 65 upon 12 minus 12 upon 7. Now what is 65 by 12 plus 12 by 7? It is 599 whole upon 84. So we have to divide it by the sum, which is difference, which is 311 upon 84, which is in turn equals to 599 whole upon 84 into 84 upon 311, because when you change the symbol it will become reciprocal. You can cancel 84 with 84 and the final answer would be 599 whole upon 311. So this was all about division of sum of two numbers by their difference. First you have to calculate the sum, then you have to calculate the difference, because the sum will form the dividend. It is the dividend here. The difference of these numbers will form the divisor, and the question is this, right? So this was all about division of rational numbers. Thank you for watching this lecture till end. We'll meet in next lecture. Till then, goodbye.